So last lecture we learned about what is meant by product design or and process design. The summary from the lecture is product design is basically adding value to certain components so that the customer buys it, and the value means basically it has two basic components: quality and cost, fundamentally. Uh, Now the question comes like in the say for the product design process, why do we need DFMEA or design failure mode and effects analysis? Why do we have to do that? Now DFMEA is a really useful analysis tool, but to understand why where it's getting utilized, we have to first understand uh, the product development process itself. So when you are trying to build this product from these components, it doesn't go that smooth. There is a development phase that you have to pass through. So you have to first come up with the concept design, and then you have to characterize and go through the development procedure, where you come up with a number of design options. From those, you have to optimize which designs you should go ahead and start prototyping. You do the prototyping and like verification and testing. All of these, after all of this, if this is nice, then you go to the product launching stage, where you actually launch the product and you wait for customers feedback. The customers provide feedback, and based on that you do further modification, blah blah blah. But the main point is this: the product development process is quite long. There is depending on the complexity of the product, it can be really long. And for simpler products, it's shorter. But for products like automobiles or like this grass cutter is not that complex like automobiles, but still like it has certain like 1 to 2 years roughly probably development time. And so in the development time, like to make the cost lower is one of the uh, fundamental focus of the development team, where you want to get or achieve certain quality that you were targeting. You want to design in a certain way that the quality requirements are met. At the same time, the cost is lower. So you want to do a lot of brainstorming. So DFMEA is a process of brainstorming. It allows you to understand where the process can fail. So sorry, where the product can fail. So a product fails means the product is not meeting the target quality. You can make any product, but you have to meet the qualities. So if either of those doesn't meet, then you cannot move ahead with this product. But this process is not quite simple. Depending on the product's complexity, this can be really complex. Sometimes it's not a one person task. So for example, whoever is designing, the designer himself doesn't quite know how it will fail. Probably someone from the testing department or manufacturing department, they also have to provide feedback on the functionality. And there is also a matter of cost. So someone has to come with so the designer might think, okay, for this machine, the product I'm developing, I can use any engine that provides minimum vibration, maximum power, and overall better quality to the product itself. But you cannot use any product, any engine. Your quality is of individual components are also limited by the cost. So You really have to optimize each of those, and there comes the role from the supply chain department. So to find out what are the optimal options, or what are the optimal conditions or components for designing this final product, really is a requires a brainstorming session among different departments: supply chain, operation, design, testing, manufacturing, all of those departments, who finally brainstorm and find out where the product can fail, or the quality might not meet, or the production can be too costly. Too costly is not probably too much of a concern, because as you move forward, you can reduce the cost, but the quality is the fundamental concern as far as product design is concerned. But again, like, you don't want to over design it so that the cost is too high. Now, if you see this one, this is a typical product development process where the y-axis along the y-axis we have the number of failures that are detected, and along the x-axis it's basically the development time from the starting to launch and then production. So here, this is a case where the failures are discovered late in the process. So initially, when the designer has the concept developed, and it's going to the characterization, they have multiple version of it, and gone to the prototyping, and like when they're launching, they have found huge number of failures. That means all the like different prototypes and all the different family of designs uh, they have invested, uh, many of those are actually waste of money and time. But this thing could be avoided if initially the designers could actually collaborate with other teams. Say, for example, analysis team, who can in the engineering analysis, there can be someone who knows finite element method and can do the simulation to find out optimal option. So you don't have to come up with like 10 different option. You can actually come with three different option that you can go for prototyping stage. And at the same time, the what kind of components you're using, sourcing that is also fundamental, and for there the supply chain department is vital. And also, like, do we have the equipments or tools that is required for this product is also important. So the operations and manufacturing department, they will have to provide feedback on whether this is actually a feasible product design or not. So it has to be manufacturable as well. So all this brainstorming or all this question is kind of listed in a document where all of these are kind of like then discussed among all the group members, and like they kind of try to figure out what are actually the real risks that they can face in the design phase, in the development phase, and then consecutively they try to resolve it ahead of time, so that they don't go ahead and move ahead with most of these problems with the product. And those and eventually, when those gets detected at the end, obviously those are gonna cause a lot of cost, and that can be really easily avoided if the product has feedback, or if it goes to the DFMEA phase, proper DFMEA phase. So here is like something that probably a DFMEA phase, good DFMEA analysis was applied on the product development, where you can see, like, during the development phase, like characterization and development phase, the failure modes were actually discovered. So they didn't even go to the testing mode or optimization. This was like through brainstorming, many of the potential design options were omitted, and this is what DFMEA can do. So yeah, and DFMEA is not just valuable for new product design development. It also can be helpful during a Kaizen project. Kaizen is a Japanese term. It means small improvement. So changes for small changes for improvement, sorry. So that thing, you can when you have a product in the market, not necessarily you keep the product in the same status. You continuously improve the design. You want to reduce the cost or increase the quality or both. You always look for option. For example, say there is a new material coming, so you just implement that new material and just say the frame material right now you're using, say stainless steel, and then you find out that in market there is a better version of material that is cheaper than stainless steel but provides better durability to the vibration, and also to the dynamics of the product, of the machine itself. Then probably that's worth like considering, that you consider the new material for the as the frame material. So these things are always important, but at the same time, how it is gonna change the and how it is going to react with other components, because everything should be synchronized. Their performance should be synchronized. You have to use a frame that goes with the engine, or a blade material that goes with the and like with the rest of the components. So all of this has requires a lot of brainstorming. You can start working on that without thinking. That's going to cause a lot of money. But if you point out all those points where the quality can fail for each changes or each development process, there comes the analysis tool DFMEA.